In this next section, we're going to strictly be talking about points of tangencies and using those tangent lines. So just a quick review. Tangent lines pass through one point on the edge of the circle and they continue onward. So this section we cover how to use that point of tangency with right triangles. So one of the theorems, it says if a line is tangent to the circle, then it is perpendicular to the radius drawn at that point. So if I were to draw a radius and connect that point on the outside, it says, this theorem says, that those are perpendicular, thus creating a right triangle should I choose a point on the line and connect it again. So then I would have a right triangle. Another theorem says that in a plane, if a line is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. So it basically says this theorem backwards. So if I have a line that is perpendicular to a radius, then it means it's tangent, or if I have a tangent line and draw the radius, that means they're perpendicular. Okay, so let's go ahead and use this knowledge and say that this piece is 15, the length of that segment is 15, and the length of the radius there is 7. So I would be able to go ahead and use this information to determine what this segment here, AB is equal to. I'd be able to use my Pythagorean theorem and set up AB. Let's go ahead and call that x. X squared should be equal to 7 squared plus 15 squared, 49 plus 225, which should equal 274. That's x squared. You take the square root of both sides, 274, and that's going to be about 16.6. So I can use my knowledge about tangent lines and how they are perpendicular to the radius drawn at that point of tangency and be able to find missing sides, whether that is the hypotenuse like AB or whether that would be one of the legs. Alright, another theorem in this section, it says that if you have your lovely circle and I have a point, any point, it doesn't matter where, I'm able to draw two tangent lines. So here we go. I will have two tangent lines, so I can draw one to one side and draw another tangent line to another side, where it only, just glances the circle, it doesn't pass through, it only passes through one point. If I have this starting point. And what this theorem says is that these pieces are in fact congruent. So if I have a value, let's go ahead and say this is 17 and this is 2x minus 5, I should be able to set these pieces equal. 2x minus 5 is equal to 17. Because I know this from this section, they would be perpendicular, those pieces would be congruent. I'd be able to solve this two-step equation by adding 5 to both sides. 2x would equal 22, and x would equal 11 after I divide each side by 2. Alright, and that's about it for this section.